All right. Hi, everyone. My name is Smriti, and this is my seventh time mentoring with Magic. I was also a mentee when I was in seventh grade about 10-ish years ago. Crazy how time flies. It is my pleasure to introduce you all to Peridot today. She is a rising, actually just started classes at Berkeley this week and just graduated from Menlo last spring. And she came into the program interested in neuroscience and computational biology. And we came up with a cool project. I'll let her talk to you about the specifics of that. My background is in computer science, so I learned a lot alongside her, and that was a lot of fun. I want to highlight a couple things just that I've learned about her and enjoyed working with her. I've been so impressed with her attention to detail, her inquisitiveness, her dedication to the project, and flexibility. We ran into several challenges, which I'm sure she's going to share, and she always tackled them with a can-do, positive attitude and diligence and just like a ferocity and fierceness. It was always about learning and growing, which is awesome, and I hope you continue to learn and grow that way, Peridot. It was a joy to work with you, and I'm excited for you to share with everyone. Please take it away.
Hi, thank you so much for that amazing introduction. So now I'll return the favor. Here's a little bit about my mentor, Smriti. So just like me, she actually grew up in the Bay Area and then went to MIT to study CS and engineering. And she's currently working in fintech at Google in the New York office. And some of her hobbies include dance and music. So as for my project, as Smriti mentioned, we were working on neuroscience and machine learning. So we decided to build a convolutional neural network to diagnose ADHD. And as for how I decided on this, I just came in wanting to do a project in ML with a healthcare focus because I did start this interested in medicine as a career, and I still am, but now I'm sort of interested in more of the research aspect as well. And so just for a little bit about our timeline, we started off looking at an overview of what artificial intelligence actually is. What is machine learning? What is the difference? Then we narrowed it down to AI and ML and healthcare specifically. And so that included finding data sets, which surprised me because there were actually a lot more data sets than I thought were available initially. And once we found the data set that we wanted to work with, we worked on picking the specific machine learning approach that would be best for that data. And we went on to do a neural network tutorial on this popular data science website called Kaggle. And then we spent the bulk of the time actually processing the data. And I can talk more about what that entailed. But finally, we got to actually create our neural network, which was super exciting. And just to go into some of those first steps I mentioned, we were looking at what is the difference between AI and ML. And in this diagram, you can see that AI is sort of the big umbrella. And then within that is the subset of machine learning. And even within that smaller subset, there's also deep learning, which is essentially neural networks with lots of layers that are very computationally intense. And as for how we picked ADHD, so I started off really interested in the idea of precision medicine, which is essentially using a lot more data about specific patients as well as patients as a whole in order to really tailor their prognosis and their treatment. And that involved sort of a literature review type of survey where we were just looking at what sort of things have been used in precision medicine and machine learning. And this is the paper that started it all. This is a paper about neurodevelopmental disorders and how machine learning has been used. And I'll just call them NDDs for short because it's hard to say. And so what do you know? They actually did this in 2011. There was a competition called ADHD 200 to encourage the use of machine learning for ADHD diagnosis. And they took MRI scans of 973 people at a total of 8 testing centers. And so what they were looking at, like I said, MRI. So fMRI is the process of imaging that detects brain activity by visualizing where oxygenated blood is concentrated because when neurons are active, they require more nutrients, including oxygen. And then just for some overview about what neural networks are. So it's basically a way for a computer to detect patterns in lots and lots of data that maybe we couldn't have detected on our own as humans. And so you can use labeled input data or not. That would be supervised versus unsupervised learning. And convolutional neural networks are specifically really good for image classification, which is why we ended up using them, because we were looking at MRI images. And they extract features, so for example, like a dog's ear, in order to, for example, classify between different images. So like dog, cat, bird, lion. And as for my experience, so I learned a lot of things that I had not expected, namely that processing the data would take the bulk of the time. That involved writing Python and shell scripts, reading and writing CSVs. And along the way, I also learned about the basics of fMRI. And also, as for like the meta process of designing our project, I think one of my main takeaways from this experience will be the knowledge that like I can pursue personal projects without needing an external structure from school. You know, obviously I'm not an expert in neuroscience or machine learning. Smriti was really helpful in that process, but you know, I'm really not intending for these projects to be like super cutting edge, like in the field or anything like that, but they're more about sort of learning by doing, and having the confidence to know that, you know, I can go from not knowing anything about a topic to building a working prototype in 3 months, which was a really big confidence booster, to say the least. And so then as for my demo, these are just 2 of the scripts that I wrote. The first one is just about creating the CSVs, which are basically just sort of like spreadsheets of data. And the right is about converting fMRI to pictures, because it actually comes in a different format called .nii. And here is our actual demo. So that is just background about where we got the data from. And then here is the structure of a CNN. You might remember from my previous slide. It's basically just saying there's all these different layers of like convolution layers and pooling layers, basically just pattern detection in different ways. And you can see you start with an input layer. And then hidden layers are just all the layers in between the input and the output layers. But by the end, you should have an output that can include a classification or something like that. And you can see how this will later be reflected in our code. And here is just loading libraries in our data. And then in machine learning, a training data set is referring to the data that is used to actually fit the model. And testing is data that you've never seen before. And you can use that to evaluate the accuracy. And then X would refer to like the actual data samples. So for us, the pixels, and Y would be our diagnostic labels. And here are just some examples of the first few lines of what our data sets actually look like, our CSVs. And it's also always good to get to know the data. So you can see there's about 60 control patients and about 20 ADHD patients that are represented in our data set here. And super cool, here's just an example of one of the slices from fMRI data. And then this is basically all just sort of pre-processing to get our data to feed into the model the way we want. And as for training and testing, you need to train, or you need to split the training data into validation versus just training, which is basically just intermediate tuning. So then here's the actual CNN. You can see, I don't know if you can read it, but there's essentially a convolution layer, a dropout layer, and a pooling layer, and then that gets repeated twice. So you can see how that sort of matches up with what our diagram looked like before. And then these are just sort of different parameters that will affect how the model actually learns. And we chose to do 20 epochs, which is essentially just fitting the model 20 different times before we get our final fit. And you can see that the accuracy actually stayed the same for most of it, but the loss is going down. And loss is basically just how far off our prediction was from our actual true output. And so you can see this graph here, the loss is going down, which is good. That's what we want. And then here is just evaluating the accuracy of the model. So you can see there was 100% accuracy on the training set and on the validation data set. And then there was 72.73% accuracy on the testing data set, which is pretty good. Although, you know, we only had 11 points in the testing data set, so it's not, you know, a huge data set at all. But and then this matrix down here is essentially just saying what is the difference between our true positives, our false positives, our true negatives, and our false negatives. So just another way to track our accuracy. So yeah, I just want to say a really big thank you to Smriti and everyone else at Magic. And with that, I'll just let anyone ask any questions if they have any.